Morning.
So for being great.
No problem. Type will start sharing first. Okay, so we will continue our lesson that we started the last time, yesterday. So we're talking about defining stoichiometry, if you remember. We defined stoichiometry as the study of quantitative relationship between the amounts of the reactants and the amounts of the products. We said that the chemical reaction will stop when one of the reactants is used up. So one of the reactants is used up, so the chemical reaction will stop. Stoichiometry, we said it depends on the law of conservation of mass, which states that mass is neither created nor destroyed, it's conserved. So the mass of the reactants equal mass of the product. Okay, we reached here yesterday. Yesterday we said that what we cannot work on the relation between the reactants and the product unless we have a balanced chemical equation. Okay, so here for example we have 4Fe plus 3O2 gives 2Fe2O3. Here for example, if it's not balanced, if we don't have 4, 3 and 2, the coefficient, so it's not balanced, so we cannot proceed. So first we should balance this chemical equation by adding these coefficients 4, 3 and 2, so we can proceed. So after balancing, now the equation is balanced. So what can I derive from this balanced chemical equation? I can first derive the word chemical equation, like this one: iron plus oxygen gives iron 3 oxide. From it I can derive the number of representative particles. For example, here Fe, it's an atom. Fe, iron, is an atom, and I have 4 here before it, so I have 4 atoms of Fe. 4 atoms of Fe. Here oxygen, O2. O2 is not an atom, O is an atom. O2 is a molecule. O2 is a molecule. So I have how many molecules? I have 3 molecules of oxygen. Fe2O3, it's a third type of representative particle. We call it formula unit. So Fe2O3 is a formula unit. We have 2 of it, so we have 2 formula units. So we have 4 atoms of Fe, 3 molecules of O2, and 2 formula units of Fe2O3. Or also from this balanced chemical equation, I can derive the relation according to the number of moles. The coefficient here, 4, 3, and 2, is equal to the number of moles. For example, here we have 4 moles, here we have 3 moles, and here we have 2 moles. So we can say 4 moles of iron react with the 3 moles of oxygen to give 2 moles of iron oxide. So here we have 4 moles, 3 moles, and 2 moles. Okay, great. We have the number of moles. We have the number of moles. How can we find the mass? Okay, we just use the formula mass equal moles multiplied by molar mass. So we will go to the periodic table, okay, and we'll find the molar mass of this element. Okay, so we will use, okay, the rule mass equal moles multiplied by molar mass. Okay, for example, here in this question, the molar mass, the number of moles of iron is 4. So we write here moles equal 4. And you will go to the periodic table and find the molar mass. You put it here, you multiply them, and then you have the mass. Okay, so by doing this, you can find the mass of iron. Just a minute, please. Okay. Okay, so let's continue, please. So here we have 4 moles of Fe, and we multiply it by the molar mass of iron. Who can please find from the periodic table what is the molar mass of iron? Raise your hand if you can. يلا يا محمد
What's the
هادي.
question again?
Find the molar mass of iron from the periodic table.
1 minute, mister, please.
Yes يا محمد.
Yes, sir, 1 minute.
Okay. Okay, I'm just waiting.
Okay, mister, 55.84.
Very good. So you multiply by 55.8. Let's say it's 55.8. Okay? So the answer is what? 200 something, 230. Okay, 223. We'll take it point 0.4. Okay? So this is the answer. Look. Okay? This is, you can put it on the calculator.
Mr.
So
Hadi, good
the
morning.
good morning.
I'm sorry for any interruption,
No, don't worry.
but I see none of the student turning on his camera.
Okay, yes,
So
please, all of you,
students
open your
turn on your camera.
cameras. Okay, please, Mister, please open your cameras.
Open your camera and raise your hand. You are there. Abdulaziz Al Majid.
عايد فيصل هادي أدري يلا, all of you open your cameras, please. Mr. Ashraf.
Yes, Mister.
Do you know sometimes there is a problem that they are opening the cameras, but we cannot see that they are opening. It happens with me a lot. Maybe they are telling you that I'm opening the camera, but there is a problem.
Okay. See, sir.
Yes, mister, the amount of people that open the camera are 9 or more, maybe.
Okay.
Yeah.
Mr. Hadi.
Yes.
So simple. I need if such problems, student can inform you, okay, and you can
Okay.
ask him to raise his hand. If he raised his hand, so he's with
Okay.
you, right? Until
Okay.
he.
Yeah, for sure. Yes, reading
Okay.
with the hands, I'm using it a lot during the period.
Okay.
Type.
Very good.
Yes. Yeah.
So, a student, if you have any technical problem, you can inform the teacher, okay, or you can raise your hand. We need to see that you are with us, not outside of the session. So thank you so much.
Thank you, Mr. Ashraf. Abdulaziz Mujdi, open your camera. Then, So we'll continue. As we said, we can find the mass multiplying the moles by the molar mass. So the mass of iron is 223.4. So look here. Okay, I have 223.4. This is the iron. The same thing, in the same way I can find the mass of oxygen, and in the same way I can find the mass of iron oxide. Type. If we add the masses of the reactants, 223 to 96, it will be 319. And the products is 319.4. 319.4 reactants, 319.4 products. What can you deduce? Yeah, Walid.
Yes, mister.
What can you deduce from this? 300, yeah.
Similarity of the reactant and products.
Okay, what is this 319 gram? This is volume or what?
The mass.
Mass. So the masses of the mass of the product equal to the mass of the
mole.
no,
I mean reactant.
reactants. Okay, mass of the products equal to the mass of the reactants. This is, we call it law of
mass.
Conservation of mass. Yes, conservation of mass. Great. So, okay, depending on this, we can derive, depending on the balanced chemical equation, we can derive all of these. We can derive the Wald equation. We can derive the relation between representative particles. We can derive the mole relationship. We can derive the mass relationship. And all of these rely on what? The law of conservation of mass. Mass of the reactants equal mass of the products. Any question, please? All of you put your hands down. Yes.
The mass, the law of the conservation of mass must be all the same, like the reactants and the product must be all the same, or no?
Yeah, for sure. In a physical change or in a chemical change, the mass should be conserved. The mass before should be equal to the mass after, or the mass of the reactants equal to the mass of the products. Yes, it's a rule, always.
Okay.
Okay. Time. So, now please. Yes.
Can you go back to the page, please?
This one?
Yes. Listen, how did you know that we have 4 atoms of iron, but we have 3 molecules? Why not 3 atoms?
Because O2 is a molecule. If I said O is an atom. Okay? O is an atom. And here you can say, instead of 3 molecules, you can say 6 atoms of oxygen. Okay, Abdurrahman? But here we are writing it as O2. So O2 is an molecule, or is a molecule. Okay, like H2, N2, O2. Okay, all of these are molecules. And here Fe2O3, this is a formula unit. I have 2 formula units. Type, here, for example, we have C3H8. Okay, C3H8. They want to find the different relationships at the previous one. So we have C3H8 he said that, look in the question, undergoes combustion. What is combustion? Keep it in mind. When they said combustion, it means it will react with what? Oxygen to give carbon dioxide, CO2, and to give also water. Okay, when they said always, when they said combustion, it means that it will react with oxygen and give carbon dioxide and water. This is a must. So these 3 will be the same: O2, CO2, and H2O. Now I want to balance it. Who want to balance it? Raise your hand. Hello. طيب just a minute please. مجدي. Hello
Yes.
مجدي.
Yes, miss.
يلا. How many carbon do we have in the reactants?
3.
3. In the products?
In the what?
In the products how much?
2.
2. This is 2 for the oxygen. The subscript is only for the element, okay, that is below it. I have here nothing, any 1, ya Majdi. Okay?
Okay.
Okay, so I have here 3, I have here 1. So what should I put here before as a coefficient? To make it balanced. Hello? Majdi. طيب.
Yes.
محمد, طيب, I will take manage محمد Ali.
Mr. Okay.
Yes, mister.
Okay, so I have 3 here. Here I have 1. What should I put in the coefficient?
3.
3, very good. So I will put 3. So here we have 3 carbon and here we have 3 carbon. Then what is the second step? Or hydrogen or oxygen first?
We do hydrogen.
Very good. How much do we have hydrogen in the reactants?
8.
And in the products?
2.
What should I do?
Put 4.
Very good. So 4 times 2 is 8 and here we have 8. Now oxygen. How much do we have in the reactants?
2.
2. How much do we have in the products?
10.
Very good. How did you know? Tell me please.
Because we multiply the subscript by the coefficient
Yeah.
CO2, which is 6.
Very
And then
good.
you also do in the H2O, and it will be 4.
Excellent.
Together it will be 10.
Very good. So 3 times 2 here. Look, 3 times 2, 6. You multiply the coefficient by the subscript. So 6. And here we have 4 times 1. It's 4. So 6 plus 4, it's 10. What should I put here in order to become 10?
In the reactant, you have to put 5.
5. Very good. So 5 times 2, it's 10. And the products you have 10. Now it's balance. Here we can put 1. Okay? Nothing, any 1. Not 0. For sure. Now I want to derive the relationship. What is the relationship? Okay. Who can tell me the relationship? Riyadh.
Yes, mister.
Yes. Tell me the relationship according to the moles, the number of moles.
I don't know, mister. I don't understand.
No, it's easy like this one. Yeah. Look here, for example, 4 moles of iron with the 3 moles of oxygen give 2 moles of iron oxide. Yeah.
Yes, mister. I'm here.
Here, look, from the coefficients 4, 3, 2. So here I have 4 moles of iron, 3 moles of oxygen, 2 moles of iron oxide. Okay?
Okay.
Type here, how many moles of C3H8?
3 moles of carbon and 8 moles of hydrogen.
No. We don't say like this. We look at the coefficient, and this is one unit. This one, C3H8.
Oh.
We say 1 mole of C3H8.
Okay.
Okay. How many moles of oxygen?
5.
Very good. How many moles of carbon dioxide?
3.
How many moles of water?
4.
Great. Okay, so this way I can derive the relationship according to the number of moles. Or I can say one representative particle, which is C3H8 with 5 molecules of oxygen, give 3 molecules of carbon dioxide and 4 molecules of H2O. Depending on what? Here, on these numbers. What do we call these numbers?
Coefficients.
The coefficients. So depending on the why should I balance the chemical equation before I start deriving? In order to add the coefficients. Only this. Okay? Any question? Anyone have any question?
No,
Great. So now we will talk about the last. Okay, here if you want to find the mass, okay, derived from the this equation, Okay, as we said, I will not take time about it because we just do it in the previous lesson. Here, for example, you have 1 mole. Okay, if you want to find the molar mass of C3H8, okay, sorry, or the mass, not the molar mass, the mass of C3H8, you multiply the number of moles, okay, multiplied by the molar mass, okay. The number of moles is 1, okay, from here. The number of moles is 1. And the molar mass, you find it from the periodic table, 3 times 12 plus 8 times 1. Okay, so it will be 44. So 1 multiplied by 44, okay, so the answer will be 44. So this is the mass of C3H8. Okay, if you want to find now the mass of oxygen, the same thing. You multiply 5, okay, times 16 times 2, because we have 2 oxygen. Okay, this is the molar mass. So you have, okay, the molar mass, it's 32, you multiply it by 5. The same thing for carbon dioxide. The molar mass of carbon dioxide is 44. You multiply it by, you multiply it by the molar mass. Okay, so here we have 3. Okay, you multiply it by the molar mass of carbon dioxide, which is 44. Okay, in hydrogen, we have 4 moles of H2O, sorry, and the molar mass of H2O is 18, so you multiply 4 times 18. So you can find the masses of all of them. Okay, look, you find the mass of C3H8, of oxygen, of carbon dioxide, and of water. If you add all the reactants here, look, 44 plus 160, it's 204.1. If you add now the products, 132 plus 72, also it's 204.1. So look, the mass of the reactants should be equal to the mass of the product. So here we have conservation of mass. Any question? Any question to here?
Me, Mr.
Yeah, what's your question?
Mr. In the oxygen, it's like the previous one. Yes, here 5 and O2. Like we can multiply it 5 times 2, it will be 10, like 10 moles, or
yeah, you can say 5 times 2, then multiply the molar mass, which is 60.
like it will be 10 moles times.
No, not 10 moles. 5 moles. 5 moles, and the molar mass of O2 is 32.
Yes.
Okay.
I mean, like if we multiply it 5 by 2, it will be 10. It will be 10 moles.
I can't say 10 moles. You can say 10 moles of oxygen atom, but oxygen molecules, you have 5 moles.
Okay.
Why to multiply it? Let's keep it like this. Only if you want, you have calculation. Find the molar mass of O2, which is 16 times 2 equal 32. Then multiply it by 5.
Okay, Mr.
Okay, great. The last idea we'll talk about it today is the mole ratio. How many times of mole ratio we can write? Look here, please. If I want to count the number of substance that I have, okay? I will take Abdurrahman Hassan. Abdurrahman.
Yes, Mr.
How many substances do we have in this chemical reaction? Count them. How many substances in the reactants?
3.
The reactants. Not the number of atoms, the reactants. How many substances? Look, here we have 1. No, this. Here we have 1, the first, second, third, and fourth. So how many substances do we have, Ya Abdurrahman, here in this chemical equation?
4.
4, very good. So I have 4 substances. If I told you how many mole ratios can I write? What is the number of mole ratios that can be written for this equation? You will say N is the number of substances, okay? N equal 4. Okay, here we have 1, 2, 3, 4. So n equal 4. And the formula you will use is, please concentrate, n into n minus 1. You just substitute n with the number above here, which is 4. So it will be equal 4 into 4 minus 1. So it will be 4 multiplied by 3. Okay, so 4 into 3. So it will be 12. So from this chemical equation, I can write 12 more ratios. So the number of more ratios I can write, okay, of any equation is n into n minus 1. This is the rule, where n is the number of substances in the chemical reaction. Okay, I will do another one for, okay. Look here, for example, let's say A. I have A plus B, okay, gives C, okay. Kareem, Kareem,
Hello?
okay, Kareem, how many substances, yeah, Kareem, do you have in this chemical equation?
Can you show me, sir?
3, very good. So n equal to?
Yes.
N equal to 3.
Yes.
Great. What is the rule, yeah, Kareem? We just memorize it now. N into n minus what? 1.
Yes.
Okay. So you substitute the n with 3. So it's 3 into 3 minus 1. So it will be equal to 3 multiplied by 2. So the answer is 6. So you can derive from this equation, okay, 6 mole ratios. How many? 6 mole ratios. Okay, please, any question till here? Just you should note this equation, n into n minus 1, and n is the number of substance. Okay, if I have AB plus CD, so I have 4, A, B, C, and D, so n equal 4. You just substitute n with 4. Then, now I will send you now an assignment. Please just wait 1 minute. Okay, you will just receive the assignment in seconds. Okay, you just receive it now. Okay, please open it and solve it now. Riyad, why did you submit so fast?
It was
Yeah.
2 questions, wasn't it?
Yeah, but too
Yeah,
fast.
it's easy.
Both are wrong.
What?
Yeah. Yeah, Riyad, why?
Mister, I thought it was correct.
Yeah, because you just completed in 40 seconds. How it comes?
Mister,
Riyad,
I
next.
thought it was the same as you, like the one that I saw.
No. Each question you should, because all the answers are very near to each other, so you should go through details.
Okay, Mister, it's my fault.
Yeah, no problem. Next time you will do, inshallah, better.
Sir, my mark is good. I submitted.
I don't know. I will send the marks now after the end.
Can I leave? I finished. Can I?
Yes, if you submit, you can leave. But please, all of you, take your time. Okay, it needs time. Okay, here, according to the questions, to the answers, okay, not all of you are answering correct. Please concentrate.
Wait, Mister, is there anything I can do to higher that grade? Or is that it?
No, yes, for sure. We have a lot of assignments every week. So, no problem, yeah, Riyad. Inshallah, you'll do better in the next
Okay, Mister.
assignments. Even you did this week 2 other assignments. Okay? How much did you get in the first 2?
I'm not sure, Mister. It doesn't tell us what our.
I'm sending the score every time. Time.
I don't see.
Time. Next week you'll do better, inshallah. No problem. No problem.
Mister, I submitted. I can leave.
Yes, submit and leave.
Okay, thank you, Mister.
Okay,
Bye-bye.
thank you, Mister. Bye.
Bye-bye.
Mister, I submitted as well. Bye.
Bye-bye.
Me also, Mister, I submitted.
Okay, great. You can leave.